feel that it'd be too big of a hitbox. I know what it'd be this good. So you have to. The idea is, you ever see this game with the triangle? No? You ever been to like a Cracker Barrel and you're like, and you see like these little boards?
No, I've never been to a Cracker Barrel.
You know, actually, I feel like we're still going to that. Also, the finish the customer. Why am I? Our test is today, Mr. President.
It
For
is.
us.
Finally, time to move on.
Something that, we used to turn on the chamber.
Yes.
Forgot if you, last week.
is simpler.
Yep. Just leave it over there. So. Alright, there is a few assignments you guys need to turn in before we get started here, specifically 27 and 28. Unless you put them in Google Classroom, you don't have to do both. But if you're not sure if you did Google Classroom, you should give me the hard copy just in case. And if you have any late or incomplete work that you were trying to get more points for, this is your last chance. Make sure I have all of that. Our test is no calculator, so clear off your desk and I'll let you get started.
Good morning, Fayetteville High School. It is Tuesday, October 1st, 2024. Please join me for a minute of silence. Thank you very much. Will you please stand if you're able for the order? Allegiance to the flag of the United States of America, and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Have a great day.
Okay, if you came in late, you need to make sure that I have your 27, 28, and any late incomplete work that you wanted more points for. I will not take those for points later today or even later this period. You don't need them during your test. It gives me a chance to grade them during your test, and I need to see what you actually did before your test. So if you did come in late, make sure you do that first before you start working on your test. Did I miss anybody? Does anybody not have the test in front of them?
Am I allowed scratch paper?
You can use scratch paper, but you need to staple it when you turn it in.
Cool, thanks.
Got some extra paper over there. Yeah, help yourself. Okay, so a couple tips here. Again, I don't know the exact curve of what this one will be. I grade these for their raw score first and then decide what needs to be the curve. So I only say that because part of the honor code is that you guys don't talk about the test after the fact. But it's also in your interest not to share that kind of information. Because if you're helping other people in other classes know what's on the test, then you could be affecting the curve to your detriment. So I hope to have these in today, but again, I have to see how my fourth period does as well before I can even start to consider out the curve. The friendly information I can give to you here is just small reminders. Quite a few of these are multiple choice, so those are either wrong or right. There's only a couple short answer, fill in the blank type questions. But there is one typo on here, which I don't think should affect you, but just in case, I don't want it to confuse you and make you think that you were doing something wrong. And so that is, regardless of which form you have, question 3, all of the answers are in millimeters, which doesn't make sense for velocity. So all of those answers in number 3 are supposed to be millimeters per second. All the numbers are fine, it's just that the units don't make sense with the question, which is my fault. Just a typo I forgot to fix. Okay, second tip, friendly tip I can give you is the back page is your free response question. So free response questions are usually either half of your points or almost half of your points. So in my experience, it's always been a little beneficial if students start with the free response, because it doesn't really take half the time, then do the other questions, and then check the free response a second time before you actually think you're finished. Making sure that you read the directions, you got the information out of there, make sure if it asks for including units that you actually did that, just double checking all that kind of stuff. But in my experience, doing the free response first and again last tends to help out students the most, since it's almost half of your points and it's not half of the work. And then finally, the last tip I would give you is before I would turn it in, I would double check and make sure you asked yourself about chain rule on every single question, since that's probably the part you feel least comfortable with at this point in the year. So anyway, take your time. You should not need all of class, but we will be moving on to starting the next unit once all the tests are in. So if you finish your test earlier, as always, just make sure that you find something quiet to work on while everyone else finishes up. Sorry, I did not realize all the tests were in. So let's move on here, but I'll give you a minute. I need to run to the restroom anyway. Give you a minute to finish up if you were working on something for another class, and then we'll talk about Unit 3 and start that other handout you picked up. I guess this would also be a good time. One of your handouts that you picked up on the way in was a test reflection page. It was not numbered for you, so you need to number it as 29. And now that you've seen and taken the test, you can fill out most of that except for the bottom part, because you don't know what your grade is yet. Again, I really think that's a good tool, especially with your AP exam, because you're not going to remember what it was that you struggled with in March. So jot those things down on that test reflection real quick, please. Let's go ahead and start to look at assignment 30 here. So this is something called implicit differentiation. So in Unit 3, so we just took our Unit 2 assessment, but Unit 3 has a lot less stuff to know compared to Unit 2. Unit 2 was a lot of small things, but again, most of that stuff in Unit 2 will carry over. So power rule, product rule, quotient rule, chain rule, that stuff is going to continue to come up. even within implicit differentiation, because the differentiation is the power rule, product rule, quotient rule, chain rule. But honestly, it's really just one step on top of what you already know, and then some practice with making sure you're comfortable with the question types. The other thing we'll do in Unit 3 is something called related rates, and related rates can be more challenging, but they're the first thing that we get to look at in here that's like very real world-ish, besides position, velocity, and acceleration, I guess. But, so, related rates are definitely my favorite topic, and we will finally get to those in this unit. Okay, so implicit differentiation. First off, what we have done so far is explicit, and I'm not going to go over this step by step because it's all typed up for you. But to be explicit, basically you have to take your equation, you have to solve it for y equals, and then take the derivative of both sides, because the derivative of y gives you y prime or dy dx. So sometimes we can rearrange this algebraically to make it y equals, and then just take the derivative of both sides. You can see they did the power rule, chain rule, and then they made their answer look nice. The problem is sometimes you can't solve an equation explicitly. Sometimes you can't solve it for y equals to take this approach. So the same question implicitly, so we're not going to solve it for y equals, we're just going to take the derivative at face value. And here's the one thing that you have to know the difference of for implicit differentiation. When we take the derivative of, let's say, 2x, the derivative of that would be 2, but we just took the derivative of an x variable, derivative of x, with respect to x. And dx over dx is like 1, because anything times itself is 1. That's why we've not had to talk about this thus far, because we've been taking the derivative of x stuff with respect to x. And dx over dx is like multiplying by 1, and of course that doesn't do anything. But notice in this example, so notice they took the derivative of a constant, said it was 0. We're used to that. They took the derivative of x squared, said it was 2x dx dx. They took the derivative of x with respect to x. But since this is essentially 1, 2x times 1 just gives you 2x in the next step. But the important one is this one. When you take the derivative of y cubed, you're still using power rule or product rule or quotient rule and or chain rule. But now, when you do the power rule and bring the power and lower the power by 1, now we just took the derivative of some y stuff with respect to x. This is super important because this is probably not 1. This is not something divided by itself. So every time we take the derivative of y, we've got to create a dy dx, or a y prime. In fact, in this question, dy dx is what they are solving for. It's the derivative. Notice, same answer, but again, sometimes we have to do it implicitly. Sometimes you can't solve it for y equals. Okay, so to say the same thing on question 2, and I would insist that you copy down the full notes here for the first 2 questions, and then part of this is kind of tedious and we'll stop doing it after 2 of these. So, y'all should be able to tell me what is the derivative of x squared? 2x. Now, also, I'm insisting for this question and the next, right, we took the derivative of x with respect to x. These will always be with respect to x unless you're told differently. Okay, what about 5x? What's the derivative of 5x? 5. And then this would be a dx over a dx also. I took the derivative of an x thing with respect to x. Okay, take the derivative of this with your normal stuff, bring the power down, lower the power by 1, but this time I took the derivative of some y stuff with respect to x. Took the derivative of y I need a y prime there. It's kind of hard to see, and I guess it doesn't really matter that you know this, but that's really just chain rule. It's like you're taking the derivative of the inside, which is y, but the derivative of y might not be 1, so that's why we have to keep up with it. Okay, what about 3y? What do you think its derivative is?
3 dy over dx.
Perfect. Took the derivative of y with respect to x. So you need a y prime, or dy dx, same thing. Derivative of a constant is 0, derivative of a constant is 0. If you're going to take the derivative of the left side, you need to take the derivative of the right side also. Now, the reason why I said most of this is pretty tedious is because most of these are dx over dx, which is like 1. This is like 2x times 1. This is like 5 times 1. Notice those derivatives should be the same way you did them on the test. But right here, we have to have a y prime. And here, we have to have a y prime. Anytime you take the derivative of something with respect to something else, you have to have that variable prime. So with implicit, it's always anytime you take the derivative of y, you need to create a y prime. So basically what I'm highlighting in those steps. Now, if the purpose of this question is for us to find the derivative, this is what I'm trying to solve for. And the next couple steps aren't the easiest, but the nice thing is with implicit, this is pretty formulaic. Implicit usually simplifies the same way. So I'm going to isolate the y primes, which just means I'm going to put the y prime stuff on one side, and anything that's not y prime, I'm going to subtract over to the other side. And the reason we like to do that is because then if everything on the left side has a y prime, we can factor it out as a GCF. And then you can undo times with divide. That's the derivative. Now there's something about this that stands out to me that does make sense. I don't know if it makes sense to you guys, but if we were talking about like a circle, and here's where x is 2, what would you, just make up a number, what do you think the slope is when x is 2? No wrong answers. Huh?
It would be undefined.
There's a slope at 2.
Circle?
Mm-hmm. Yeah.
-1.
Okay, so right here, -1 is a good guess, right? But how did he know to look up there and not down here, where it might be +1? See what I'm saying? So it makes sense for things that are not functions, like circles. Circle's not a function, it doesn't pass the vertical line test. It makes sense that your derivative has x's and y's. You plug in 2 for x, and you've got to plug in whatever this y is if you want this one, and you got to plug in 2 for x and this y if you want that slope. And so notice our derivative, which is our formula defined slope, has an x and a y. So just having x sometimes is not enough. Okay, but the important part there is highlighted. Every time I did y, I created a y prime. Every time you take the derivative of y, y prime. If you can ingrain that in your head and remember it every time, you are, other than a couple practice questions, you already understand implicit. Okay, go down to question 3. So let's just say this a few more times. Really try to hammer it home, and then I'll have you practice one of them that we will check together. Okay, so this is the second and last time you have to do all of this, but 2x would be 2x dx over dx. Again, normally I don't care if you write that because that's going to just be 1. Okay, what about this? -5xy. How am I going to take the derivative of that?
You do both dx over dx and dy over dx.
Okay, I was looking more for which rule should we use.
Product.
You've got to use product rule. The -5 is a constant. You can pull it out front if you want to. That's an option. But x times y is product rule. You can't product rule, I told you, product rule, quotient rule, chain rule, power rule is going to follow you the rest of the semester. And then next semester we're undoing those things, so those basically still follow along with you. So I could take the derivative of x, which would be 1 dx over dx. I'm taking the derivative of an x thing with respect to x times y left alone. Now I'm not creating a y prime here because I didn't take the derivative of y this time. But then on the other side, I'll leave x alone and take the derivative of y. If the derivative of x is 1, the derivative of y is 1, but I just took the derivative of a y thing with respect to x. Okay, 3y squared, same thing, normal power rule, bring the power down, lower the power by 1, but you have to have the wherewithal to realize I just took the derivative of a y with respect to x. Make sure you take the derivative of the other side also. Now, the reason I don't insist that you write every one of these down every single time is, again, dx over dx is like 1. It's like something divided by itself. It's not actually that, but it works out that way, so we just tend to do that. So if that's 1, and that's 1, and instead of saying dy over dx, I'll just do y prime, just because I think it looks cleaner. They mean the same thing. And this was 6y, y prime. So notice, I took the derivative of y here, created a y prime. I took the derivative of y here, and it creates a y prime. Every time you take the derivative of y, you need to create a dy dx or a y prime, same thing. And if you forget both, well, if you forget one of them, you're not going to get the right answer. You're going to think you're doing it right, and then you're going to miss it. But if you get both of them, or if you forget both of them, you should know something's wrong because you're trying to solve for the derivative. You're trying to solve for y prime. So the simplifying here, this is the normal stuff. I don't know. We could try to distribute the -5. We could isolate the y primes. So I'll just leave everything that has a y prime on one side, subtract the other stuff over to the other side. The reason we do that, just like 2 questions ago or even 1 question ago, if these both have a y prime, we can factor it out and then undo times with divide. Again, it's not the easiest simplifying, but implicit basically always solves the same way. So that's why if you practice it a bit, there's the derivative. Now, I have no idea what that equation looks like, but it's not a function. It would not pass the vertical line test. So it makes sense that his derivative needs an x value and a y value to know which one you're talking about. But the highlighted stuff is really the only new step. Simplifying only gets easier as the year goes on. Product rule, chain rule, quotient rule, hopefully you feel great with those, but if you don't, you still need to be putting in a good effort so that they get easier over time. Okay, any quick questions about example 3 before we jump to example 4? Okay, so 4, what would the derivative of this be?
3x.
Okay, and do I need an x prime or a y prime or anything?
No.
No. Okay, what about y cubed?
It would be 3y and then you do y prime.
Almost. You brought the power down, but you still need to lower the power by 1, so it's 3y squared. And make sure you take the derivative of the other side. Don't just take the derivative of the left side and leave the right side the same. Okay, this one looks on the easier side to solve. We are trying to, notice we took the derivative of y 1 time, so we have 1 y prime. Y prime is the derivative, that's what we are trying to solve for. So this one's easier because you could subtract the 3x squared over, you could divide both sides by 3y squared, and I guess if you wanted to simplify it some, you could at least cancel out the 3's. That would probably cancel out the 3's on a multiple choice question. So it's not really any harder than you've been doing, but again, it is one extra step, and it's kind of like chain rule. If you don't think about the y prime, then you're going to keep missing stuff until you do think about it. Any quick questions about example 4?
Yes, sir.
Okay. then, where's example 5? Huh. There is no example 5. Okay, let's do one more together, and then I will let you try 7 to see if you can do it with just a couple of examples here. So, number 6, the derivative of y is 1, just like the derivative of x is 1, except I'm taking the derivative of y with respect to something else. In this case, with respect to x. So it's got to have a y prime or a dy dx. Minus 3 times this stuff. And the only way to take the derivative of x squared times y is product rule. So I could take the derivative of x squared times y left alone. That does not create a y prime because I didn't take the derivative of y. Plus, leave the x squared alone, and then take the derivative of y. Now that I'm taking the derivative of y, it needs to create a y prime. Okay, but I did leave a mistake in there. So what did I not do? See if you can find my mistake. Yeah. Right. If you're doing the derivative of the left side, you better do the derivative of the right side also to keep it balanced. Now, sometimes you want to solve for the derivative, so we would need to maybe distribute that -3, isolate the y primes, factor out a GCF, and undo times with divide, like we've done on the last few questions. However, this question doesn't ask you to find the derivative. It just wants to know the derivative at 0, 1. So that means I should plug 0 in for what? And 1 in for
Y.
okay. So does that mean I plug in a 1 for y prime?
No.
Now, y and y prime are two different things. I don't know y prime. X is supposed to be 0. Y is supposed to be 1. X is supposed to be 0. I don't know y prime. Y prime and y are two different things. And then plug in 0 for x. You're left with y prime. All of that goes to 0 is equal to negative sine of 0. And what is negative sine of 0? So the slope at the point 0, 1 to that equation, I have no idea what that graph looks like, but I know at that point it's temporarily a horizontal line because it has a slope of 0. So once again, took the derivative of y, y prime. Didn't take the derivative of y, left it alone. Took the derivative of y, y prime. Trying to highlight the derivative of y's to y primes to help you see that. Okay, so number 7 is the only one I'm asking you to try on your own before we talk about it together. So go ahead and write down what you think you should do. And we will practice this more than just today, so you don't have to feel like you have it mastered, but you should have a very good idea of what the process should be. Okay, does anybody need more time for 7? Okay, this should have become 8x. This should have become minus 18y y prime. Every time you take the derivative of y something, you need a y prime. Unless you're taking the derivative with respect to y, which I don't think happens in this course at all. And make sure you change this to 0. Not just the derivative of the left side, but also the derivative of the right side. Okay, and then to solve for this, you should have subtracted the 8x over and undo times with divide. So you could say that's the derivative for your response question. That's perfectly fine. Of course, we are normally going to reduce this though. This would be like 4x over 9y, something like that. Is that what y'all got? So again, it's really just this one step. If you can remember, every time you take the derivative of y, create a y prime, then other than the simplifying, which just varies question to question, that's all there is to implicit differentiation. Okay, the last thing I'd like to do with you guys is I'd like to look at a full previous FRQ, which we have not done together thus far this year. And I picked this one out because the first part is how they tend to ask you to do implicit differentiation in FRQs. And I thought it would be a good opportunity for us to look at and talk about other parts so you guys get a good feel for how FRQs go. As the year goes on, you're going to realize FRQs are by far the hardest part of your AP exam. So we just have to practice quite a bit so that we get more and more comfortable with them. Okay, but part A, if I wanted to take the derivative of this, how do I know it's going to be implicit differentiation?
With x and y.
Okay, so it's got x's and y's mixed up, right? Part A says show that the derivative is this. So the nice thing about implicit, which I think you should hope that you get one of these on your AP exam this year, they don't tell us exactly what you're going to get, but they're telling you what the answer is, and they always do this with implicit. It's just your job to show that it's equal. So 2 of the 9 points just come from us doing implicit and showing that we get the same answer that they get. So let's go ahead and do that real quick. 3y cubed would become 6y squared y prime because I took the derivative of a y, plus 6x squared y. I'm going to have to use product rule here, so I'm going to pull the 6 out and worry about it later. So the derivative of x squared times y left alone plus x squared left alone times the derivative of y. There's another highlighted one. Second time I took the derivative of y, so a second y prime. Minus 12x squared would become minus 24x. And what's the derivative of 6y? Good. Not just 6, but 6y prime. Third time we took the derivative of the y, and then this needs to equal 0. So we're doing the derivative of both sides. So I'm looking at the scoring guide here because I want to talk about the scoring of parts B and C that are not implicit, but I just want y'all to see sometimes how challenging these are and why we have to try to be on top of our game as much as possible here. But they give 1 point for this. If it looks like you used implicit differentiation, they give you 1 of the 9 points. I mean, that's already 10% of this FRQ score, just knowing to get all 3 of those. The second point in this FRQ actually comes from solving this and making it look like that. So, I don't know, we could distribute the 6. We could isolate the y primes, which again just means leave the y prime stuff on one side And anything that's not a y prime thing, move to the other side. Okay, why is it helpful to have y prime stuff only on one side? Because that's your hint to the next step.
So you take out the white line.
Good, so you can factor it out as a GCF. Because if you don't know why that's helpful, then you're less likely to think to do that before that. And then you can undo all of this times with divide. Now I will be honest, I don't know how picky they are, but this is equivalent to this. I think you would be crazy to stop here though. Personally, I would say I could factor out a 6 out of the denominator and negative 24 out of the numerator, or negative 12 out of the numerator. And then those two could reduce to be negative 2. And then finally, I don't know, I would distribute the negative 2 and probably put this one first, just because they put it first. Distribute the negative 2 to get this second because they put it second. And then after these two reduced, I've got an x squared, a y squared, and a plus 1. So this is the only time I can think of for FRQs where they tell you what the answer is and they just want you to show that that's the case. So that's the type of question, unless you just run out of time, there's no reason for you to not get both points. 1 point right at the beginning to show that you knew was implicit, and then the second of the 9 points comes from showing that it all simplifies to what they got to. So since this is almost half of Unit 3, the implicit, this is the important part of the FRQ, but you guys okay with all those steps? You get the general idea? Is there anything you want to quickly clear up about that? Okay, then let's go ahead and do parts B and C together as well. But again, B and C, these are not Unit 3 specific. That doesn't mean that they would not be in on a Unit 3 test or some version of these. But both of these parts are pretty difficult. But again, I can't even begin to show you every possible way that the AP test likes to twist and turn and make questions slightly different. So more practice we get, the better. Okay, part B, write an equation of each horizontal tangent line to the curve. Okay, well how do you get horizontal lines? The what is 0? Not the equation. Okay, so I was going to say slope, but a better word would be derivative. Derivative and slope mean the same thing. Horizontal lines is when the slope is 0. So horizontal lines occur when the derivative is 0. That's something I ask you to know for today's test. It's nice if you have that memorized because it gives you a fighting shot on something like this. Well, do we know what the derivative is? What if I didn't know how to do part A? Would I know what the derivative is?
No. Or well, you would because of the...
They gave it to us. They told us what it was. So even if we didn't think we knew how to do part A, they told us the derivative. So here is where the derivative is equal to 0. Okay, I guess you could multiply both sides by the denominator. But when does a fraction equal 0? When what's 0? Okay, so I really only care about when the numerator is 0. Now, here's where it's different than you guys are used to. This is where it can become uncomfortable because it doesn't fit the 1,000 questions that you've practiced in previous math courses. we can still solve this, even though it's got x's and y's. You could say both of these have a 2x that we could factor out. I could set this factor equal to 0 and solve, and I could set this factor equal to 0 and solve. So I know the slope is 0 when x is 0 or when y is 2. And notice, it's not like I'm doing anything super fancy here. I factored and set each factor equal to 0. You've done that a million times. You have not done it a million times where some of it's x's and some of it's y's. So again, that's where you start to feel a little bit uncomfortable. But if we look back at the original equation at the top, I'm not going to scan back and forth, but one time we could plug in 0 for the x's. So that would make it look like 2y cubed plus all of that goes to 0 minus all of that goes to 0 plus 6y equals 1. And then for this one, to use that, you would have to use your calculator to solve this. It's not a quadratic, so we can't use quadratic formula. And soon we will do a circuit on calculator stuff to make sure you know all the calculator skills they expect you to be able to do. Okay, so part A was 2 points. Part B, we've already earned several points. They give 1 point if you showed that you knew the derivative had to be 0. They give 1 point if you solved it. If you solved where the derivative equals 0. They give 1 point for thinking about when x is 0 and solving. And they give a 4th point if you think about where y is 2 and solve. So if I plugged 2 into that top equation, not this derivative, because the derivative tells me things about the slope, not locations, not points. This would be 2 times 8 plus 12x squared minus 12x squared plus 12 equals 1. So how many x squareds do we have? Okay, so I get a statement 28 equals 1. What does that mean? So y equals 2 doesn't even exist on this equation. The 4th point in this comes from showing that y equals 2 doesn't make sense. Plugging y equals 2 into the original equation gives you an untrue statement. So y never equals 2 in that equation. It doesn't make sense. So there's 4 parts. It's not that hard to know the derivative needs to be 0. It's a little unusual to solve one like this, but that's the 2nd point. Plug this in, solve. Plug that in, try to solve. There's 4 of the 9 points, so that's almost half of the credit. But notice how part B has a lot of stuff in there that just looks different than you've done in the past. Okay, anything special about B that you'd like to ask before C? Okay, and let's finish up with C. Okay, the line through the origin with the slope -1, slope -1, is tangent to the curve at point P. Find the x and y coordinates of P. Okay, so there's 2 ways that the scoring rubric goes about this one. I don't know which one y'all think is easier. But what's another, probably the easiest for you to see is another name for slope is what? So we could set the derivative equal to -1. If you want the slope to be -1, you want the derivative to be -1. And if we take this approach, they give you a point just for stating that. Okay, and now here's where there is enough information to go further, but it's hard to see. The line through the origin was slope -1. What's the equation of the line that has a slope of -1 and goes through the origin? Okay, and then plus 0, right? So, again, read that first little statement. The line through the origin with the slope of -1. We can make that equation. The reason you have to make that equation is it tells you what y is equal to in terms of x. I can't solve this yet because it's got x's and y's in it. But if I know what y is in terms of x, everywhere there's a y, we could put a -x and they give a point for that as well. Again, not intuitive. They don't tell you to do that. There's no hints to do that. It's not going to jump out at you, but you need to see how I came up with that equation based on their information, and someday in the future, maybe months from now, that might be how you need to get unstuck there as well. Okay, and so I don't know, the rest is just solving here. This would be 4x plus 2x squared over 2x squared plus 1. We could multiply both sides by the denominator.
Would it be just 1 over 1 since it's -x? I like the square.
Okay, I'm still going to purposely leave something off here so that y'all have something to look for. So I knew the derivative, I knew the slope had to be -1. I set this derivative equal to -1. Because of this, I changed all the y's to -x's, and then I got an equation that only had x's in it. Multiplied both sides by the denominator so I didn't have fractions, distributed the -1, combine like terms, put everything set equal to 0. This was a quadratic, so you could use quadratic formula if you prefer, but I solved it with factoring, -1/2 and -1/2, so x has to be -1/2. But what else did this question ask for? Okay, how do I go about finding the y value? Okay, plug -1/2 in for x into what though? Very good. The original equation, not the derivative. The derivative is going to tell you slopes, not points. And if you plug that into the original equation and solve, you would get 1/2, and you have to do all that for the last and 9th point. So again, I'm not trying to scare you by showing you parts B and C, but I'm showing you how algebra stuff that you guys have seen before is often asked in ways that isn't the most comfortable, which is why we want to be as prepared as we can so that we have more time for parts like that. So next time I see you, we will review implicit. We'll practice a little bit more implicit, and then we'll probably move on to the next topic as well. But again, this is almost half of your 3rd unit. So since we are a few minutes ahead here, I guess I can share the puzzle with y'all a little early. Again, I do hope to have the grades in gradebook today. It might not happen till tomorrow, depending on if I get any meetings thrown at me this weekend, or I'm sorry, this afternoon. But remember, just like the first one, you have to wait till everybody makes up the second one before you can see yours. So that will probably be like Wednesday of next week. Some people were absent today because they're sick and they didn't know they were going to be sick, so they're not signed up for advisory this week.
This is totally okay if it like doesn't count because I totally forgot that I had the extra paper scratch paper. But I was wondering why my grade was so low for the circuit, and then I realized I forgot to turn this in, which had like all my work on it.
Okay, that's fine. I'll change it this time. Just make sure you turn it in next time.
Cool. Okay. Thank you.
All right, did y'all do this?
No.
No? This might be too hard for you, I don't know. But y'all have about 8-9 minutes here, so if you have something for another class you'd rather do, that's always fine. A puzzle is always just for a change of pace, not required. Find them all? Next time I'm gonna put one up there that's not in the picture just to see if you can figure out which one's missing. just a minute here, so you need to start getting your stuff together.